Okay, now we're going to talk about description of data. So when you perform an assay of any kind, or when you carry out an experiment, you will gather some kind of observation, and those are the definition of data: observations of a variable. That is what data is in science, right? And how do you handle your data? Okay, how do you deal with all those variabilities that are found from a bunch of numbers that may look like meaningless, right? And then how do you deal with the uncertainty in our data? Okay, so the answer for that is by using a mathematical tool called statistics. It's how you deal with that. So statistics will provide a mean to deal with the variability and uncertainty. So you cannot perform an assay just once and assume that you have the right data. You may have to perform it several times and get maybe standard deviation and average of your values and see if there's any kind of a correlation in there. Okay, so that's how you do it. So it provides method to summarize, analyze, and interpret observations of natural world. That's what statistics does. So statistical methods are used to reach conclusion based on data with a certain probability of being right and wrong. So it doesn't make sense, but hopefully it does. That's what you do in science, right? So there are important statistical terms you need to understand. So population, like I said, you're not going to carry out one experiment and you're done with that, because you need to repeat it certain times to make sure you can gather similar observation through your experiment over and over. So when you do that, you will gather the data through a group of events, group of observations and experiments. That is a population. Okay, so a population is a similar things you are finding from your assays or your experiment. Okay, and the sample, again, and how many times do you carry out your experiment? 2 times, 3 times, 5 times, 10 times, which is the good enough sample size. So because you'll have to repeat it so many times, you need to have a good sample size in your experiment. Okay, and the variable, so if you carry out multiple experiments, so they're not going to be identical all the time, so there will be some variables in your data. So how do you deal with that? So characteristics of a population that can be measured is a variable. Okay, understand all those terms. And the description of data, when you have a group of data, okay, how do you know that if the data values are close to each other or very dispersed, or if they're dispersed, how close are those are? Okay, so when you try to measure the closeness of your data, or the distance among your data, you measure these things. So when you measure the central tendency, so you can measure the average by adding up all those data divided by the number. You can see what the central value is. That's the average, right? So you can determine the central tendency once you did that, and you can measure the distance of each data point from the central tendency. That'll show you how dispersed your measurement is, right? You can also measure something like mean, median, or mode. That's another way of measuring the central tendency. Mean is similar to average, right? Sum of all the values you get divided by the number. That's what mean is. And then median is what? The middle value. If you have like 10 numbers, which one is the middle value? That's the median. And the mode is what? Most frequently happening number, or the data. That'll be the mode. Okay, so they all show you the central tendency of your data. And the measure of dispersion, like I said, so if you know the central tendency, you can see how scattered your data is. Okay, so that'll be expressed as a range. Range means what? The smallest value, data value, from that to the largest data value. That the distance is the range. Okay, and then deviation could be another way of doing that. So distance of a data point from the mean is deviation. Okay, so when you manufacture something, okay, a medical device, for example, you don't want to have deviation among your product. They should meet all the specifications that are required for your products. So that's how you can measure, the off-quality products, right? And the variance of population is another way of measuring the dispersion. So it is mathematically measured as the total squared deviation divided by the number of measurements. So sigma means the sum, the total, right? So mean minus the data you measured, and then you scale that, and you do that so many times, depends on how many data points you have, and then you add them up and divide by the number of your data. So that's the variance of population. Okay, and variance and standard deviation of a sample. So variance square is, again, it can be measured as square deviation from the mean divided by number minus 1. So that's probably standard deviation, square root of the variance. So when you did the first lab that measures standard deviation or coefficient variance of your micropipette, probably you dealt with one of these values, right? So that measures the variation or the range of your pipette measurements. Okay. The coefficient variance is another way of doing that. Standard deviation divided by mean is the coefficient variance. Okay. Summarizing data by mean and measure of dispersion. Okay. The mean value plus minus standard deviation, that shows you how scattered your data is. Okay. Or it can be expressed as mean value plus minus standard error for the mean, or it could be expressed the mean value plus minus 95% coefficient interval. Or it could be shown in the graph form as well. Okay. So if you had a consistent experiment or assays, and then your process to make the product has been very consistent, and everybody's well trained, and you are using the good raw material, then you should not get a lot of deviation, a lot of standard deviation in your product quality, right? And then description of data, frequency, distribution, and graphing methods they are used when you describe your data. Okay, so number of times, I'm sorry, I'm typing all the emails. Number of means times a particular value is observed is the frequency, how often they show up. Okay, distribution, pattern of variation for a given variable, that's a distribution. Okay, you can take a look at your textbook pages to understand those terms in more detail. And then normal frequency distribution, normally you will have a bell-shaped pattern. Okay, that'll be normal. But if your distribution is kind of skewed, it's not normal, then you may have a little different shape. Okay, so a little kind of far away from the mean. So it could be bimodal if they are kind of cornered in two different ways, two different peaks. Okay, so bell shape is ideal, of course. In the normal distribution curve, the center of a peak is the mean, and then from the mean you will have a symmetrical distribution from there. Okay, so if everything is happening around the mean, that will be ideal. Okay, standard deviation determines how far or how fat or thin the curve appears from the peak, and then how your curve is close to the mean or far away from mean, right? For any normal distribution curve, take a look at these. They fall into about 68% of area that lies about plus minus 1 from the standard deviation. 95.5% lies within plus minus 2 standard deviation. 99.97% lies about plus minus 3. So the scattering should not be very wide. That's what it means. Okay. And finally, controlling product quality. Like I said, the quality is measured how close your products are in meeting the specification. And your product should have the same quality over and over. Whoever makes those products, whatever the materials, batches that are used, they should meet the specification the same way, right? That's very important. So variability should be minimized in your product quality, of course. And whose job is that? Of course, it's everybody's job. Manufacturing operator, QC technicians, and then even the president of the company. They are concerned on the quality of the product, right? So normally, QC technicians will measure the samples and see how uniform those samples are from your product manufacturing processes, right? So the size of variability provides a clue about how good your manufacturing process is at your company, of course. And then normally you can use these tools in measuring your product quality control chart. Six Sigma, probably you heard that if you already took the class BIOT 102. There should not be any deviations. It's a 6 Sigma, very small deviation, which will be really good if you can make that, right? And control chart everything should fall in within the control. So lower warning limit, upper warning limit, hopefully your values would not go over those. Okay, lower control limit. So your control chart should show those maximum or minimum limits, and everything should fall between. Okay, and there may be some values going out of those limits. We call those outliers, and those are not good in statistics in your quality control. Okay, and outliers may be a signal that there's a problem in your process. Then you need to find out what the source of the problem is. Okay,